Hi, in this video we are going to talk about derivative as a function. So given a function f of x, the derivative of f of x, which is f prime, is, geometrically, it's the slope of the tangent line to the graph of f of x at the point x f of x. And algebraically, it's the limit h goes to 0, f of x plus h minus f of x over h. This is also called the limit definition of derivative. And practically, derivative means the instantaneous rate of change of f at the point x f of x. So here is one example. Find the derivative of x squared function by using the limit definition. So if we write the limit definition and apply the function x squared, first x squared and minus x squared will cancel. And then if we take the limit h goes to 0, we are going to have 0 over 0. So if we factor h and simplify, then we are going to have limit of 2x plus h as h goes to 0, which is 2x plus 0, and that's equal to 2x. So then we say that the derivative of x squared is 2x function. Another example, find the derivative of the function square root of x by using the limit definition. So we just write the limit definition, put the points into the function which takes the square root, and then if we take the limit at first, we are going to have 0 over 0. So in this case, we cannot factor here anything, but from our limit techniques, remember that in these kinds of cases, we just multiply top and the bottom of this fraction by the conjugate, which is square root of x plus h plus square root of x. So if we do this, what's going to happen? We are going to have on the top square of the first square root minus square of the second square root, and all divided by h times the conjugate. So square root and square cancels, and on the top we have x plus h minus x, which then x terms cancel because one is plus x, the other one is minus x. So, and then we have h on the top, h on the bottom. We can also simplify those h's. And then if we take the limit as h goes to 0, we will have 1 over 2 times square root of x, which can be also written as 1 over 2x to the minus 1 over 2. Now, another example, find the derivative of the function 1 over x by using the limit definition. So the limit definition, if we write the limit definition and apply the function which takes 1 over the input, so we will have this expression, and then if we take the limit h goes to 0, we will have 0 over 0. So if we combine the fractions on the top so that we can make the subtraction there, and we will need to cross expand the fractions, the first one by x, the second one by x plus h. So if you do that, now both fractions have the same denominator, and then x minus x plus h, but this x plus h is in the parentheses, so that minus distributes to both x and h. So we will have x minus h on the top, and then there is a division by x times x plus h, and if we flip this h over 1 and multiply, we are going to have times 1 over h also. So x minus x cancels, and then this minus h and h also simplifies. Minus h will simplify to minus 1, and the h on the bottom will simplify to 1. Then when we take the limit of this expression as h goes to 0, we will have minus 1 over x squared. So if the function is 1 over x, then its derivative is minus 1 over x squared. So if you probably have noticed, these functions, each of these functions in the examples are actually power functions, and their derivatives turned out to be old power becomes a coefficient, and the new power is actually one less of the old power. So if we make a table for the results, like x squared became 2x. As you see, 2 became a coefficient, the old power became a coefficient multiplied, and the new power became 2 minus 1, which is 1, so x to the 1 is x. Or like the square root of x, it's a power function with power 1 over 2, and look at the derivative, 1 over 2 times square root of x, but that's also equal to 1 over 2 times x to the minus 1 over 2. So that 1 over 2 is actually the old power, times the new power is minus 1 over 2, but that's actually the old power 1 over 2 minus 1. And then the last example, 1 over x is equal to x to the minus 1, and it became minus 1 over x squared. But minus 1 over x squared can be written as minus 1 times x to the minus 2. And as you see, this minus 1 is the old power times the new power is minus 1 minus 1. So actually, this is not a coincidence. This is actually, these three functions are actually power functions. And then there is a rule for power functions, which is called the power law. And that's x to the n prime, or derivative of x to the n, is n times x to the n minus 1. This is called power law. And this is the one of the first important rules we need to know. So if you wanted to prove the power law, so when n is an integer, let's say we have x to the n, and if we apply the derivative, limit definition of derivative, we are going to have like this expression here. So if we take the limit as h goes to 0, it's going to give 0 over 0. So we need to expand x plus h to the n, and then simplify that with minus x to the n, and then also simplify with the h on the bottom in this order. So if we do the binomial expansion for x plus h to the n, we are gonna have this expression on the right, which is actually binomial expression, which is very standard. And here n by 1 is a combination, which is n factorial over 1 factorial times n minus 1 factorial. So that's equal to n. So if we write this derivative, limit definition of derivative for x to the n, we are going to have, after the binomial expansion, x to the n plus n times x to the n minus 1 times h plus the other terms. But look at the terms. The first term is x to the n, the second term, and the third, and the fourth, and the rest of the terms have a copy of h. So, but the x to the n in the first expression, in the parentheses, simplifies with minus x to the n, and then the rest of the terms have h in common. If we factor that h and then simplify it with the h on the bottom, we are going to have this expression here. And then when h goes to 0, now look at the terms. Like the first term now has no h after the factorization of h, but the second term has an h. The third term will have an h, and all of the other terms have a copy of h. So when h goes to 0, except for the first term, which is n times x to the n minus 1, the rest of the terms will be going to 0. So the result is n times x to the n minus 1, which we just called the power law, or the power rule sometimes. X to the n's derivative is equal to n times x to the n minus 1. So old power times x to the old power minus 1. And using the power rule, we can just look at quick examples, like derivative of x to the 5 will be 5 times x to the 4. X to the 10th derivative will be 10x to the 9. Derivative of x to the 200 will be 200x to the 199. Cubic root function or root functions, they are also power functions. So cubic root of x is actually x to the 1/3. So its derivative is going to be 1/3 times x to the minus 2/3. 7th root of x to the 6 is actually x to the 6 over 7. So its derivative will be 6 over 7 x to the minus 1 over 7. And then also, if we have like reciprocal functions, like power function on the denominator, they are also power functions. Like 1 over x squared is actually x to the minus 2. So its derivative is going to be minus 2 times x to the minus 3. 1 over x to the 10 is actually x to the minus 10 function. So its derivative is going to be minus 10 times x to the minus 11. And then also these two last two functions, x and 1, they are also, commonly going to be used in our computations and stuff. So they also are power functions. Like x is actually x to the 1, because the first power of any number, any function, is that number or function. So x is equal to x to the 1. So it's a power function. Its derivative is going to be 1 times x to the 0, but x to the 0 is 1. So it becomes 1. Derivative of x is 1. Derivative of 1, well, it's also a power function, x to the 0. Because x to the 0 is 1 if x is non-zero. So x to the 0 is 1. Then as a power function, we take power 0 down, multiply it by x to the 1 less power, but that doesn't matter because we are multiplying that function by 0, which makes 0. So derivative of 1 is 0. Okay, now we can actually have some rules for derivatives of functions. So like when you have two functions f and g, which are differentiable functions, then their sum and their difference are also differentiable. So when f and g are differentiable, the limits here exist. And f plus g prime, if we use the limit definition, can be written this way. And then if we write f plus g as f of x plus h plus g of x plus h, and so on and so forth, we can write it that way. And then we can separate the f terms and group them, and then we can also take the g terms and group them. But then what happens? The group of f terms, as you see, it's nothing but the limit definition of derivative for f, and the second limit is actually g prime. So f plus g prime is equal to f prime plus g prime. Very simple. And similarly, we can also show f minus g prime is equal to f prime minus g prime. And if we have a constant number c, then the constant number times f prime is equal to constant times f prime. Okay. Again, we can show these two also just like we showed f plus g prime, just using the limit definition. So here are some examples. Let's say we have a polynomial x to the 4 minus 7x squared plus 5x minus 10. So these are actually summations and subtractions of power functions, which also are multiplied by some numbers like minus 7, 5, minus 10. So actually we will use the power rule, and then we will use the other summation, subtraction, and multiplication by a constant rules. So if we take the derivative of x to the 4, it's going to be 4x cubed. If we take the derivative of minus 7x squared, it's going to be minus 7 times 2x, which is finally minus 14x. Derivative of 5x will be 5 times 1, which is 5. Derivative of minus 10 is actually minus 10 times derivative of 1, which is minus 10 times 0, so it is 0. Another example, if we have, let's say, 6 times cubic root of x to the 5 minus 7 over x squared plus 8x minus 2, then first we write the cubic root and the division by x squared as power functions, like 6 times x to the 5 over 3 derivative and minus 7 times the derivative of x to the minus 2 and plus 8 times derivative of x minus 2 times derivative of 1. So we will have 6 times 5 over 3 x to the 1 less power, so 10 times x to the 2 thirds, and then we will have minus 7 times minus 2 times x to the minus 3, which is plus 14x to the minus 3, and we will also have 8 times 1, which is 8, and minus 2 times 0, which is just 0. So numbers, when we differentiate, if there is no x next to them, like just numbers are, when they are just alone, then the derivatives will be 0. Okay, here is a definition, like, we have said that f is said to be differentiable at a point if the limit definition exists. So f is said to be differentiable on an interval if f is differentiable at every point in the interval. Okay, and then there are other notations for derivative which will be used. Let's say we have a function y equals f of x, and its derivative can be denoted by either f prime of x or y prime or dy over dx, which is called Leibniz notation, the third one. Or it can be shown df over dx, or it can be shown f of x differentiated with respect to x, like d by dx f of x. And also capital D f of x or capital dx f of x. These are also notations for derivative. Sometimes f prime of a can be also denoted by dy over dx evaluated at x equals a. So that's also again a Leibniz notation. And then we can have higher derivatives, like if, for instance, f is differentiable 2 times, then f prime is also differentiable, which means f double prime, which is the derivative of first derivative, also exists. Okay, so f prime is called the first derivative of f double prime is called the second derivative of f. In a similar way, if f is differentiable n times, then the notation f nth derivative of f is denoted like this: f to the superscript in parentheses n of x. That only means that the nth derivative of f. So here is an example. Let's say we have a function x to the 6 minus 5x cubed plus 3x squared minus 7x plus 4. The first derivative will be 6x to the 5 minus 15x squared plus 6x minus 7. The second derivative will be 6 times 5x to the 4, which is 30x to the 4, minus 15 times 2x, which is minus 30x, plus 6 minus 0. And then the third derivative will be 30 times 4x cubed minus 30 times 1 plus 6 times 0. So 120x cubed minus 30.